Okay, we are back. This is Math 200. We're looking at the Chapter 10 note packet from Newton, and we're on 10.4. That is page 18 in the note packet. So let's go. When we remember, logs are a fancy way of writing exponents. And remember when you had like base things, when I multiplied x squared times x to the third, I ended up adding the exponents. X squared times x to the third was x to the fifth. So in log land, when I add, that's equivalent basically to multiplying. So if I have log base 7 of x plus log base 7 of 4, I can actually write this all under the same log base 7 of 4x. And that's it. So add in log land means multiply. And again, you have to have the same base logs, just like when in order to add the exponents, when you're multiplying x squared times x to the third, it has to be like bases in order to add the exponents. So same thing, but kind of in reverse, right? They're adding, and so we're going to multiply. So this is 5, this is 8, log base z of 5 times 8 is 40. And that's it. Multiple additions. So we got x times 10 times x plus 3. That is log base 2 of 10x times x plus 3. And we can put it all together and do the distributive property. 10x squared plus 30x. Put that in parentheses, log base 2. So we know it's the whole thing, you know. Now, don't make that into a times. That's still just a plus. It's separated by the logs. Log base 2, log base 2, log base 2. And then all of those adds mean I take that, multiply it by that, multiply it by that. All right. Okay, lovely. Then divide. When you divided like bases, you subtracted the exponents. So in log land, when we're subtracting, that means division. So log base 7 of x divided by 4, like so. Okay. 40 divided by 8, that's log base z of 40 over 8 is just 5. Now this is a little tricky because it's log base 4 of x minus log base 4 of 10 minus log base 4 of x plus 3. So let's always, when you got an abstract thing like that, let's think back to easier things when you worked with numbers in math. Remember that? So let's go 50 divided by 2 divided by 5. What would you have done there? We would work from left to right, correct? So you do 50 divided by 2 and get 25, and then divide it by 5 and get 5. So basically, you took 50 divided by 2 and then divided by 5, and that's how you ended up with 5. Another way to think of it is you never ever really divide fractions, you multiply by the reciprocal. So we could have said that's like 50 times 1/2 times 1/5, and then that's 50 over 10, which is 5. Okay, so same thing's going on here. Log base 4 of x over, because that's minus, both of them are in the denominator, 10 times x plus 3. And then again, we could do the distributive property there. I didn't in the notes, I just stopped right there and called it a day. But you could have x over 10x plus 30. That would be fine. All right. Okay, so lots of fun with logs. So now another little trick. And this is Price is Right. Come on down. Remember Price is Right? They would say, come on down. You're the next contestant on The Price is Right. So the way logs work, if you have an exponent on a log, you can pull it down front. So look, on page 19, we got log base 7 of x to the negative 3. When you have a log base with something there and then a power on it, you could take this power and you could pull it down. So you got negative 3 log base 7 of x. It's always true. Okay, let's look at another one. log base 5 of the third root of x. So really, that's log base 5 of x to the 1/3 power, and then come on down. You can pull that 1/3 down in front. Okay, and so now you might say, well, why? Why do we get to pull that down? And these are kind of hard examples to explain it. Let me make one up quick. This isn't in your note packet, but if we had log base z of x to the 3rd power. Well, look, we could say, we could pull it down and just say it's 3 log base z of x, and then we're done. But now let me explain why you get to do that. This, remember, is shorthand for that. And remember, in log land, when you have multiplication like that, that's what we were doing in the section just right before this one, the page before, we could have written it like this, right? Multiply in log land means plus. So we could have log base z x plus log base z x plus log base z x. Well, those are like terms. 1 log base zx plus 1 log base zx plus 1 log is 3 log base zx. Now, don't do it like that. Just say, come on down and pull that down front. But that's why you get to do it, okay? All right, so what if they want me to write everything as a single log and then get all this junk crammed in there? 2 log base 5 of x plus log base 5 of 4 minus 3 log base 5 of x plus 5. Oof. Okay, so first, let's reassemble. Basically, we want to write it all as 1 log base 5 of something. Some big mess right there. That's the plan. So this is going to become log base 5 of x squared. I'm going to pull that back up. Log base 5 of 4 minus log base 5 of x plus 5 to the 3rd. I'm pulling that back up. Go on back up. All right. Plus means multiply, so I got log base 5 of 4 times x squared on the top. Minus means divide, x plus 5 cubed on the bottom. And there we go, all under the same log. Lovely. All right, what if we want to write it out as complicated as I can? Some are difference, multiple logarithms. So that is going to go the other way. So log base b of x cubed z over the square root of y. So now we want to write it out as many terms as we can. So we're going to say log base b of x cubed z over y to the 1/2. We're going to say that's log base b of x to the 3rd plus log base b of z minus log base b of y to the 1/2. And then we're going to pull those down. Come on down. And come on down. And so here's our final answer. 3 log base b of x plus log base b of z minus 1/2 log base b of y. Zoinks. That's quite a lot. All right. That was number 1. And then what about this? Log base b of 16, but they don't want you to use your calculator. They want you to use the fact that they tell us log base b of 2 is equal to 0.43. So look, if I know that, I can write this as log base b of 2 to the fourth power, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. And then I could say, come on down. So I got 4 log base b of 2. But now I know log base b of 2 is 0.43, so I can replace that with 0.43 times 4. And 86 cents doubled is $1.72. All right. That's a trick you can do. Whenever you multiply by 4, double what you have, 86.86, 86 cents, and then double it again, and $1.72. And you can, well, maybe you can do it in your head too. Log base b of the 4th root of 3/2. You might think, well, we sure can't do this, but we sure can, because look, this is 3/2 to the 1/4 power. We'll pull that 1/4 power down. We got log base b of 3 times, I'm putting it in parentheses because remember that's minus log base b of 2. And now we know log base b of 2 is 0.43. And they also gave us log base b of 3, which was 0.68. And so we subtract those two and then multiply by 0.25 or 1/4. And so that is 0.25 times 0.45. Oh, that should be a 5. Right, 0.68 minus 0.43, that's 0.45. And then, let's see, I think I got the right answer anyway, but let's double check it. 0.25 times 0.45 is, nope, 0.1125. Oh, so that's a mistake on the key again. I'll have to upload that to 5. All right. So now using your calculator for these, there's log, log, and there's log ln. Log ln is the natural log. You'll see that in business a lot. Log log, that's log base 10. And that's called the common log, and that's usually what we're using for logarithms. And if you're in the world of business, you'll probably use ln, but everybody else uses log, base 10. So let's look at this. Put this in your calculator, the log of 10,000. And so they're being lazy. They're not writing what it actually is. It's log base 10 of 10,000. That's what's going on there. And so that ends up to be just 4. 10 to the 4th power is 10,000. Log base 10 of 0.001, that is -3. That's 1/1000th. So if there was a 10 there, 10 to the -3 power is 1/1000th. And log of the square root of 10, well, that's going to be 1/2, of course, because this is really log base 10 to the 10 to the 1/2. So it's saying 10 to what power gives me 10 to the 1/2. Well, that's 1/2. All right. So what about if they say solve log of 3x is equal to 1.3? Well, think about what that is. That you don't really need, well, you need the calculator to do the exponent, but you don't need the log button, because look, this is log base 10. So sneak the 10 in there, write this as an exponent. It's 10 to the 1.3 power is equal to 3x. And you take 10 to the 1.3 power. Let me do that. calculator. 10 to the 1.3 is 19.95 to 6, and that's equal to 3x, and then we divide it by 3. Dang, that's another mistake because I didn't divide by 3. I just left it x. So divided by 3 is 6.6508. And so that will round to, 4 decimal places, 8, 7. So 6.6509 is the correct answer. And that on the thing, it says divided by 3, but I didn't divide by 3. So when we divide that by 3, we get and then subdivide by 3. And that's the 6.6509. 6.6509. Okay. Let's hope there aren't any more mistakes. All right, and so for ln of e to the 4th, well, now ln is just a fancy way of writing log base e. That's the natural log of e to the 4th. Well, think about e to what power is e to the 4th? That's just 4. So, but if you take ln e to the 4th power in your calculator and hit enter, it'll kick out a 4. Ln of the cube root of e. Well, again, think about what that is. That is log base e, e to the 1/3. So it's 1/3. Or if you do it in your calculator, it'll print out 0.3, repeating 0.3333 forever. All right. So let's take a look at page 22. Solving ln 2x plus 5 is equal to 3.4. So that's log base e of 2x plus 5 equals 3.4. So we're going to write it without the log. We're going to write it as an exponent. So e to the 3.4 equals 2x plus 5. Subtract 5. E to the 3.4 minus 5 equals 2x. Divide by 2. And so now you want to enter that into your calculator. You don't want to do it early. Like a lot of times students are like, oh, I'll do e to the 3.4 first. Then you have to keep writing all those numbers. Otherwise, if you round it to tenths or hundredths there, it's going to be off by a more than it has to be. All right, so you leave it like this. You do e, that is second, and then ln, that's e to the power 3.4, and then minus 5. Then hit enter. That's 24.964100005. And then divided by 2. And that's how we got the 12.48205. And then they want it to, again, with the 4 decimal places, so 12.4821. And here, I'll show you the sequence on the next one, all right? So I'll hold the calculator up to the camera. So we got A is equal to P e to the RT. So this is investments when it's compounded continuously. P is principal, $2,200. E is just E. That is like pi. It's a non-terminating, non-repeating decimal. It's an irrational number. and then 0.06 is the rate, and 4 is the years. So we'll do that. We'll do 4 times 0.06 before we enter it in. So it's e to the 0.24, 2200 times, and I'll show you how to kick that into your calculator quick. And then we'll do a change of base problem. And then I'll do the next section. We're already at 20 minutes. Okay, so to click that into your calculator, you're going to hit 2200 times, and now we want to do E, so you're going to do second, and then the LN button. And it'll kick up, see what it kicks up there? E to the power. So e to the power 0.24. And then end parenthesis, and then enter. And there's our answer. So in 4 years at 6% compounded continuously, $2,200 will turn into $2,796.75. Or 74 cents. It's 0.748. So I rounded up. Banks don't. All right, and now one last problem. Change of base formula. So your calculator has base E, that's the natural log, and it has base 10, that's the common log. But some fancy calculators, you can put in whatever base you want. But if you don't have a fancy calculator, if you have one just like I have, you can do, it's called the change of base formula. So if I want to change this base, it's log, oh wait, that's a 5 though. You got to write down the correct problem to the 1/6. Okay, so look, this is log base 10, that's the LOG, of 5 divided by log base 10 of 1/6. And so when you type that into your calculator, you have to remember this end parenthesis. That's the number one mistake I've seen students make on this. All right, so let's take a look. One more time at the calculator, LOG button, log. All right, can you see it? Okay, there you can see it. Log of 5. And now you have to hit this end parenthesis. So many students forget to do that and then they get the wrong answer. Divided by log of 1 divided by 6, end parenthesis. Okay, let me turn it so you can see without the glare. Okay. Okay, and then we hit enter. And so that is negative. Did I want 4 decimal places for that? 4 decimal places again. So that is negative 0.8982444402. And then again on the notes, so negative 0.8982. On the notes I have it as I did the top and I did the bottom and then divided. And you can do it that way too. But it's a lot of writing of numbers. So you could circumvent it, just remember that second parenthesis.